Good morning, good afternoon. My name is Phil Laidler. I'd like to welcome you to this webinar on building applications in a 5G era, introducing AWS Wavelength. So I'd like to welcome all of you who are listening. I'm going to run through a little bit of logistics first. So you are all in listen-only mode. And if you need to contact us, please add a comment. But also feel free to ask any questions that you have that are generated from the materials we present. And the questions, you ask them by clicking the little icon on the left here and entering the question for the panel. We will do our best. We'll endeavor to respond to your questions during the Q&A session. Those questions we don't get around to, we will get back to you with a summary at the end. And that summary will also include a recording link for your colleagues and also the slides of the presentations you're going to see. Please do tweet and share us on Twitter and encourage others to join and encourage your colleagues to listen to the recording later. So I'd like to now run through the panelists and the presenters for today's session. There's myself, Phil Laidler. I head up the consulting practice at SDL Partners. And first up, I will be inviting my colleague Dalia, who heads up our Edge practice. Dalia is a principal consultant at STL, and she's going to take us through an overview of Edge Cloud. Then we have Bala, who's the head of product marketing for AWS Wavelength and 5G Edge computing. Bala's going to provide us with an overview of AWS Wavelength and the key benefits that application providers and enterprises should expect to get from Edge Cloud. He's also going to set out more specifically how AWS Wavelength brings these benefits and bring us some examples. We're also delighted that Sebastian, who's the co-founder and CTO of YBVR, and he's going to take us more specifically through what YBVR has done in terms of providing immersive streaming experiences to sports fans, both at home but also in venue, and how they've used AWS Wavelength to open up whole new opportunities for them. So that's going to be a really interesting actual case study of how an application provider has exploited the power of edge compute to bring about innovation and extend their service offering. Finally, my colleague Ria, who's a consultant at STL Partners, is going to wrap up with a summary of what is the edge opportunity from an operator perspective. As I say, we are going to discuss the questions you raise at the panel session, so please, anytime you want to raise a question, do so. Right, well, without further ado, I'd like to hand over to my colleague Dalia, who's going to kick us off with an overview of Edge Cloud.
Thanks, Phil. So as Phil mentioned, I'll just be running through a bit of context and background around what Edge Cloud or edge computing is all about. So the first thing to note before we deep dive on edge computing specifically, just to understand the dichotomy and the choices that developers and enterprise face today when they're thinking about how they deploy applications and solutions. And really there's on the one hand, you have kind of local computing. So applications are very much tied to the end devices, or they are deployed on traditional on-premise compute on site. And that's usually using some form of proprietary system, or you have the cloud. Each one comes with its different benefits. So the great things about keeping software and applications local is that it can be more reliable. There's less need to rely on a wide area network, which sometimes fails. The other thing about keeping that traffic, say, more local is that there's also a cost often to transport all that data back and forth from a cloud. You're able to ensure applications can have low latency, so there's less of a lag between where the application is processed and where the end user sees the results of that, or where the data is generated. And then the last thing, there's increasing concern around data privacy, and a lot of the time enterprises in particular want to keep that data on site to ensure that they have control over where the data lives. On the other hand, the growth of cloud has come with lots of benefits. The first thing is that cloud is always about flexibility and being able to access compute resources in a scalable way. So if the application needs more compute resources, or there are more end users, then those compute resources can be scaled up easily. Or vice versa, if the application only needs to be used temporarily, then you only need it for a specific amount of time. The other great thing about cloud is, it's device agnostics. You can access the application no matter what end device you're using, whether it's different mobile devices or different IoT actuators, whatever it might be. That application is still accessible most of the time. The last two things, one of them, mobility. One of the challenges with processing applications on site is that once you leave the site, you don't have access to the application. Cloud kind of eradicates that problem. And then the last thing is about compute power. And obviously with the hyperscale data centers that underpin the cloud, there is almost infinite amounts of compute power, which is hugely beneficial for certain applications, particularly around AI and machine learning, for example. So Edge really is all about bringing that the benefits of cloud to more local, compute domains. So whether it's on site, on device, it's being able to have more cloud native platforms that are supporting the applications at points that are outside of just the cloud. The new thing that or the new domain within edge computing that we are really going to touch on today and discuss, and it's where AWS Wavelength is focused on, is the idea of a mobile edge compute or a 5G edge compute. And what this is all about, I guess, in a nutshell, is being able to access edge compute capabilities, not just on site or maybe at an end device or maybe in a regional data center, but it's actually having edge computing at almost mini data centers within the mobile network. And what that means is, from an application perspective, is that you can capture the benefits of edge computing, but also 5G. I know a lot of the audience on our webinar today are probably quite aware of 5G coming from the telecoms industry, but for those who aren't and who are from other industries, it's worth just touching on what 5G is all about. And we know that there are enterprises and developers out there who probably caught on to the hype, but are still trying to work out what its benefits are as a technology. In a nutshell, the new 5G mobile standard, it is about higher speeds, but it's not just about bandwidth and those higher speeds. It's also about the ability to better serve applications through a lower latency network. It's also about being more reliable. So it's more reliable as a network particularly compared to other previous wireless technologies, and being able to better support things like Internet of Things applications with the ability to support millions more devices, as well as reducing the strain on those devices' battery life by being more power efficient or energy efficient. The other thing about 5G that's a bit less well known outside the industry is that it's built on a software-based architecture, which is quite fundamentally different to previous generations of mobile technology. And so what this will allow the network to do is behave in a way that's much like cloud applications and cloud platforms. So being able to be flexible and programmable to meet the specific needs of specific applications, and also, configuring the network using tools that are cloud native, that are akin to what developers and enterprises are used to when they are modifying and creating those cloud-based applications as well. APIs, for example, being some of those tools. So the last thing is, so this is what the technology is all about, this idea of mobile edge computing, but what's the big deal and what are the key benefits? We'll find out quite a lot more from Bala and Sebastian later on in the webinar about types of use cases, and specifically use case and applications that are starting to leverage those benefits today. But at a high level, we see that there are advantages across these three main stakeholder groups. So there are benefits to the end users, where edge computing can improve the end user experience. There are improvements to the developers who can unlock new revenues by developing differentiated applications, for example, and also enterprises who can use edge-enabled solutions to optimize their own business processes and how essentially how their core operations run. Some of these benefits have kind of flashed up, and there's a whole range depending on the use case. I guess one example, just to bring this to life, is cloud gaming. So gaming platforms are, still at a relatively early stage, but are starting to evaluate the use of mobile edge computing to enable cloud gaming. And what this will mean is that, rather than the gamer having to invest in expensive PCs to run their high-end games or their AAA titles, they can use the compute power at an edge cloud to render the game and to pay for games and also the infrastructure in a more kind of subscription-based, cloud-based consumption model. And the reason why Edge is needed in that scenario is because the ping time or the latency must be very low for the gamer to have a kind of adequate, solid experience. So something, for example, a 200 millisecond latency, if you're running the game from the cloud, would be too high. The cloud gaming model, therefore, will allow gamers to play games in a completely new way. They don't need to be tied to that expensive PC, and they don't even have to invest in the PC in the first place. It's also really interesting for the gaming companies because they can access new customer bases which were affected by these barriers to adoption. So potentially markets where there was a large share of the market that would not be able to play maybe hardcore games or high-end games because of the cost of buying that PC, sometimes the cost of also a fiber network to be able to play multiplayer games, and also even the cost of the games themselves, paying it up front. So it's quite disruptive, and it can also, cloud gaming is also disrupting the market because it's removing control points, it's changing who the key players are across the value chain, changing the role of, I guess, console manufacturers, for example, have been a key control point in that ecosystem. So that's just one example of how mobile edge computing can really change the dynamics or the business model in a particular market. But there are more to come, and I guess we'll find out some more use cases in the following presentations. So on that note, I'd like to introduce our next presentation, which will come from Bala from AWS Wavelength. He's going to be introducing Wavelength further and also talking about some of the key benefits and the use cases around Edge Cloud that they're seeing today.
Thank you, Dalia. Wavelength is an AWS infrastructure offering that is optimized for mobile edge computing applications. With Wavelength, we create what are called Wavelength Zones. And these are AWS infrastructure deployments that are embedded within the CSP data centers at the edge of the 5G network. AWS already enables developers to serve end users worldwide with low latencies today with the existing infrastructure we have. However, we see there are a lot more applications coming up like smart manufacturing, machine learning, autonomous driving, live event streaming that need even lower latencies across the mobile network. To perform, these applications need to access compute and storage like many applications today, and they seek to leverage the cloud today. However, today, accessing the cloud in a traditional mobile architecture requires several hops on the network, from the device to the cell tower to the metro aggregation sites to regional aggregation sites to the internet and then to the cloud. And this creates tens of milliseconds of delays of latency. 5G is significantly faster than 4G, but as long as we have to deal with the transit latency associated with these multiple hops, customers will not be able to see the full benefits of the advancements in 5G technology. And so what Wavelength does is really brings those AWS servers right to the edge of the 5G networks, so application traffic can avoid all those extra multiple hops that adds tens of milliseconds of latencies in round-trip transit time. And we have to think about Wavelength not only in terms of latencies or round-trip transit times, right? By moving compute and storage closer to the consumption or the generation point for data, you are also reducing the amount of traffic that needs to be backhauled or served from a central location. And you can have better QoS profiles for your end traffic because you're not transiting across a public internet, and you have more control over the routing path for your application traffic. One of the most important things about AWS Wavelength is that it brings the same exact infrastructure that is used in the AWS region closer to the end users. The compute and storage services that are available in Wavelength are the same familiar Amazon EC2 compute instances and EBS-based storage for your application storage requirements. And you can use ECS or EKS to run your container-based applications. You can extend your virtual private cloud to include Wavelength Zones. So for any existing AWS developer, there is absolutely no barrier to overcome if they want to start trying to deploy their applications on Wavelength. And essentially, there's no learning curve. And it's not just the core infrastructure services. Wavelength zones will be part of your single pane of glass management for all your AWS services. All the AWS tools that you're familiar with, CloudFormation, CloudWatch, CloudTrail, they all work with wavelength zones as well. You can log all your API calls using CloudTrail. You can continue using your familiar and powerful AWS services to manage, secure, scale your applications, including services like identity and access management, EC2 auto scaling, and you can access AWS services running in the region like DynamoDB or S3, others in the same way as you do in the cloud today. And this is how you access those services back in the region. AWS Wavelength Zones are connected to a parent AWS region using a high-speed service link. So applications running in the Wavelength Zones can easily access resources from the rest of your VPC endpoints that are residing in the region over a managed, secure, high bandwidth link. Okay, now let's get a bit more geeky. I promise you this is the geekiest slide I have. So if you've worked on AWS before, or if you're familiar with developing applications in the cloud, this is a pretty simple diagram. When you start developing your applications on AWS, one of the very first thing you do is you create your own VPC or a virtual private cloud. VPCs let you provision logically isolated sections of the AWS cloud where you can launch AWS resources in the virtual network that you define. So you control the selection of IP addresses, the creation of subnets, the configuration of route tables, everything within that VPC. And a VPC typically spans all the availability zones in that region. Now, if you want to deploy resources in a wavelength zone that is parented to that region, what you need to do is you just need to create a subnet in that wavelength zone just as you would do for any other availability zone. It's as simple as that. And then there are a few other things that you should keep in mind when you think about wavelength. First, the control plane for managing the wavelength zone runs in its parent AWS region. Second, like I mentioned in the previous slide, if you want to access services in the region, you do it over that service link, that high bandwidth secure service link that we talked about in the previous slides. And third, you must have noticed a new construct there in the orange box, the carrier gateway. That is essentially the gateway that enables resources in the wavelength zones to communicate with devices on the telecommunication network. So it is a gateway to the telco network and to the internet. Now let's talk about the things you have to consider when you architect your applications to run across AWS regions and the wavelength zones. How do you decide what needs to run in the wavelength zones and what needs to run in the region? As you must have guessed, just moving your entire application to the wavelength zone is probably not the most efficient way of doing this. Wavelength zones are designed for applications that need 5G devices to connect to the compute infrastructure with ultra low latencies, or applications that need high and consistent data rates from these devices on 5G networks to the compute infrastructure in the wavelength zone. Now, we recommend that you architect the edge applications in a hub and spoke model, with the region providing the most scalable, resilient, cost-effective options for most components in your application. And you can run application components that are less latency sensitive or that need to persist state, such as databases, training ML models, and backend worker processes in the region. And then you run application components that are latency sensitive in the wavelength zones. The machine learning applications are a good example to talk about this. So we would recommend that you run your model training workloads on the wavelength zone. The model training should happen in the region. However, depending on the applications, you would run the inference in the wavelength zone because you need the results of that inference with the least possible amount of latency. And that brings me to a summarization of the wavelength benefits. The first benefit is obvious: low latency, high bandwidth access to users and devices. How that manifests in terms of user experience differs from use case to use case. For example, in the media and entertainment world, it might mean lower startup times for stream consumption, faster application performance during uploads, or minimal number of hops to compute servers that reduces jitter and variability. Higher bandwidth can lead to higher throughput for content downloads. In the autonomous driving space, it might mean that vehicles can communicate with each other or with the infrastructure much faster. For healthcare, it could mean getting assistance in diagnosis instantly so that you don't miss visual clues from the images that you're examining. So it differs depending on what domain you are and what use case you're talking about. Now let me talk about the second and third benefits together. If you're an existing AWS customer, you're using the same APIs, the same programming tool, the same development environment to develop applications for the edge. You get the same elasticity, the same flexibility, the same pay-as-you-go pricing models that you get when you develop on AWS Region. And again, these benefits manifest differently for different use cases. If you're a media production company, it means you have easy access to compute infrastructure close to media production or media consumption. And that provides an alternative to on-premises compute that is expensive to lug around or maintain. And it's elastic and it's flexible and it's always pay per use. So it's lower capex. If you're a manufacturing firm, it means you don't have to have server infrastructure on your shop floor to do processing, video processing or video analytics or quality control applications in real time. So it again manifests differently for different use cases. And then the last benefit is the ability to scale deployments efficiently. It's easy to scale your edge deployments because all you need to do to add wavelength zones into your virtual private cloud is like I said before, pretty simple. You just add the wavelength zones into your VPC. The semantics of scaling operations are very simple that way. Wavelength zones are connected to the AWS regions with high bandwidth secure connection. So you also have seamless access to the entire range of AWS services in the regions, allowing you to scale your services and your infrastructure efficiently. So that's one aspect of scaling. There's another benefit of scaling operations and your deployment. You can develop your application once and deploy it to a global base of 5G users without having to negotiate individually with every telecom carrier in the world. So if you're a developer with a cool idea about an interactive application that needs to reside closer to the mobile user, you don't want to have to negotiate with every single telco in the country or across the globe to host your application on their edge platform. With Wavelength, you can deploy the applications to any of the wavelength zones we offer. And today we have wavelength zones on Verizon's 5G network, and we have announced plans for wavelength zones in EMEA with Vodafone, in Japan with KDDI, and South Korea with SKT. So as this footprint grows, you will have instant access to a global 5G customer base. In the US, we now have wavelength zones on Verizon's 5G network in Atlanta, Boston, Dallas, Miami, New York City, San Francisco, and Washington, D.C. And wavelength zones across more locations in the US and worldwide are coming soon. And this is a quick overview of the use cases that can be enabled with wavelength and edge computing. The first one is healthcare, where AI/ML driven video analytics and image matching solutions can help doctors speed up diagnosis of observed conditions, such as recognizing polyps during procedures. Uh, connected cars. Connected cars need low latency access to compute infrastructure to run data processing and analytics so that they can monitor data from sensors for secure connectivity, for in-car telematics, and for generating safety warnings. Wavelength also provides the ultra low latency needed to live stream high resolution video and high fidelity audio and embed interactive experiences into live video streams. Video analytics at the edge provide the ability to generate real-time statistics that can enhance live event experiences. In the manufacturing or the smart factories use cases, industrial automation applications use ML inference at the edge to analyze images and videos to detect quality issues on a fast-moving assembly line so that they can trigger instantaneous remedial actions. And with Wavelength, you can enable these applications to be realized without having to use expensive GPU-based servers on the factory floor. And this is just a short summary of the many use cases that are possible with AWS Wavelength. you should really be thinking of wavelength and 5G edge computing as an innovation toolkit, because there are so many more use cases that are yet to be discovered. And that brings me to my last slide, the obligatory logo wall slide. And we're really pleased that we have we have very innovative companies here trying to do something new on AWS Wavelength. And together they represent different industries. They represent use of different capabilities available at the edge. Some use analytics at the edge. Others use ML inference at the edge. And then there are use cases that serve content from the edge. And they represent large and small. They represent large corporations and small startups. So it's a varied mix of early adopters that we are seeing for AWS Wavelength. And now it's my pleasure to introduce the CTO and co-founder of YBVR to talk about his experience using AWS Wavelength. Sebastian.
Thank you, Bala. I'm looking forward to tell you about YBVR and our use case with AWS Wavelength. Let's start with a video that will give you an overview of what we do at YBVR and what we've done with Wavelength.
Hi, my name is Sebastian Amengual. I'm the co-founder and CTO of YBVR. YBVR is a video streaming platform focused on immersive video streaming. Live events such as sports, music, things where if you can't be there, we want you to feel like you're there. Video quality in 360 immersive videos is really critical. If you're in a 360 video and the quality is not great, it's blurry, your whole world is blurry. We're talking about a massive amount of bandwidth. We're talking about uplinks of hundreds of megabits per second. So we really need a very, very large network, and 5G is what we need. By using the edge computing, the mobile edge, we can send the video from our 360 cameras, from our 180 cameras, wirelessly through 5G to the edge, and then from the edge down through 5G to your device. We give you the ability of watching all those cameras real time, and then the use case becomes really interesting, because with your device, you would be able to see a lot of different perspectives, different cameras, additional statistics, additional replays, and that can really enhance the in-stadium experience. For us, it's really a privilege to be able to work together with two such amazing companies as Verizon and AWS, because our entire infrastructure was already working on AWS, which is of course an industry leader, is the industry reference. Supporting that from AWS to Verizon MEC, which is based on Wavelength, was really simple. One of the great things about edge computing is that you can offload some of the computing from your device to the edge. So your device can become smaller, it can be lighter, it can have longer battery times. The ideal device that we foresee is going to be something pretty much indistinguishable from your sunglasses. And that will be a device that will cover both virtual reality and augmented reality. It will change the way you watch sports, it will change the way you watch live events. We really think this is going to change the world.
Well, I hope that video gave you an idea of the high-level understanding of what we do at YBVR. Basically, we're redefining the way people watch sports, redefining the way people watch live events, redefining the way we interact and we entertain ourselves with new immersive technologies. We've designed a streaming platform from the ground up with a completely different architecture from your regular video streaming platform, and we can provide set of functionalities that are really disruptive, different, interactive, engaging compared to your traditional, more linear type of streaming. In this slide, we can see some things about the YBVR experience, features such as the immersive control room, where we can see here on the left, we can see a lot of different viewpoints, all of them, all those small thumbnails that you can see in the image, all those are like running live channels where you can switch immediately and see all the different perspectives. We do immersive videos in 360, 180 videos where you can just move around. You can watch them with a VR headset, or you can watch them with your phone, with your AR, augmented reality headset. And you can switch between cameras with what we call instant camera change, meaning there's no buffering, there's really no lag in the switch, and you just click on a camera and it will just jump automatically to that camera. So it really invites you to explore, to be the one in control of the experience, to be the one really interacting and seeing things from your favorite angle. And the same applies for what we call immersive replays, which is a functionality where you can be in control of a replay. If something exciting happened during a game, you can just go back and see it, and you can see it, pause it, go back and see it also in multi-camera. So you can pause it, change camera, see the replay from different angles. You can be the one really making the call if something happened or not during the game. So it's a quite exciting experience. Let me tell you how we integrated Wavelength in this architecture. And for that, we're going to start with what we did before Wavelength. So this slide is giving you a high-level architecture of our over-the-top streaming, which is what we had before we did this Wavelength integration. It's important to understand this so we understand the entire journey we went through. Starting from the left, we have what we call our immersive production, which is really our 360, 180 streaming cameras. We also integrate that with existing TV production. So all your new cameras and the existing cameras, all of them get synchronized, get packed together in this production setting venue. We send them to AWS, to the region of AWS, so the main centralized AWS through typically a fiber link, where we do a bunch of functionalities, video processing optimizations, and then through a CDN, it will go to your device, which be it a headset, a mobile, tablet, even a web browser. This works very well for worldwide streaming because it's based on standard CDNs. CDNs are very good at streaming, but it has a big disadvantage. This type of architecture will give you around 30, 40 seconds latency end to end. So from something happening until you see it in your device, we have like 30 seconds. Most of the time is done processing the video, preparing it, uploading it, and so on. Then come Wavelength. We went from those 40 seconds to approximately 800 millisecond glass-to-glass latency. So from something happening until you see it in your device. And that's because we designed a completely different architecture using Wavelength. And we have now what we call our low latency backend. And this is excellent for in-stadium delivery. So our use case is we have the same production, but now instead of being home, you're at the stadium, you have your phone, soon you're gonna have your AR headset, and you can watch other things. Maybe you're not sitting very close to the action, or maybe you just want to see what's happening in the locker room while the players are playing. So you can have access to all those different cameras, all the statistics, all the 360 video with less than 1 second latency while you're sitting at the stadium and still enjoying the game. So it's really a way of enhancing the in-stadium experience to the next level, something that doesn't exist. And we can mix both of them, and we actually do. So now with the same production to the same type of devices, we can use both ways of streaming, and we make use of both modes of both region zones of AWS. So for the OTT global streaming, we use the AWS region, whereas for the low latency in-stadium delivery, we use a Wavelength edge computing zone. And in this diagram, we can see a bit more from a geographical perspective, the same architecture. So on the left, we have the region. This is specifically for the lower latency use case. So for the sub-second low latency use case, we use the AWS region mostly for support system. So for things that are like, as Bala anticipated before, for things that are really not latency sensitive, or for things that have a smaller amount of bandwidth, things such as configuration, discovery, analytics, basically our control plane of our backend solution. And there's control traffic going between the AWS region and Wavelength using that dedicated link that, again, Bala was talking about. And on the Wavelength zone is where we do the video streaming. So the Wavelength zone is dedicated for us to the heavy lifting of moving the video from the venue and back to the devices. And here we can see that in venue, we really have like two very distinctive type of activities. We have the production, where we have the cameras, the preparation, sending the video up to the cloud, and we can do a 5G upstream for this. It does not have to 5G upstream, but using 5G for the uplink really is very cost efficient, and it simplifies a lot of productions, whereas as opposed to having to hire and to deploy a dedicated fiber for this uplink, if the stadium is already 5G covered, and most stadiums in the world are or are going to be very soon, we can just use 5G for the uplink and send the video traffic with 5G. And we use also the 5G downstream, sending it back again to the devices. So here's where you can really see why AWS Wavelength makes sense, because the video is not really going too far. We're just sending a lot of traffic, so really like data savings, traffic savings, and traffic optimization is the main use case for us here. but the video traffic is just staying very close to the stadium. It's going to the closest wavelength zone and then back again to the stadium. Whereas if we didn't have wavelength, we would have to send this video all the way over the internet, and it's really complicated to make it work over a best effort network as the internet with this sub-second latency. It just really wouldn't work. So for us, literally, Wavelength is opening a new use case here, a new commercial use case, which is being able to do in-venue streaming. So being able to provide this same experience that we provide to the people at home, to the people attending the actual event. And they have this higher requirement. At home, you probably don't need 1 second latency, but if you're there, if you're really seeing it with your eyes, you cannot have your phone 10 seconds late, not even 5 seconds late, right? Like you need to be able to watch it in less than a second latency, so it feels like it's real time. So those are like the main architectural use cases, and we have 3 main key takeaways that we wanted to discuss. First of all, is the migration from using the AWS region to a wavelength zone is almost effortless. For us, we had the advantage that our entire backend was already running on AWS, on your standard AWS region. We use basically EC2, so their computing offering, and it was very, very simple for us to port it to wavelength. Pretty much the only relevant difference is this carrier gateway that Bala mentioned, which means that your systems are going to have an IP in the 5G network. It's just a small network configuration or reconfiguration. The amount of effort we put in this migration was really, really low. And that's the beauty of Wavelength, that it's your AWS with all your tools, all your APIs, all the things that you already know about it, but on the edge computing. Whereas other edge computing solutions would mean porting all your stack to a different technology. This is just basically moving it to a different zone. The second point is that having this direct connection to the 5G network is opening new use cases for us. So it's opening a use case of being able to do the 5G uplink. So using 5G network for uplink in our cameras, and it's simplifying then our infrastructure. We no longer require fiber there. And it's really opening for us the use case of in-venue streaming, which is a very interesting market. And it was really not available for us before because of this 30-second latency that we had. But thanks to this, to Wavelength and the direct connection to the 5G network, now we can serve the 5G devices with less than 1 second latency. So it really opens this new use case, this new business for us as a company. And finally, that we're looking forward to a deeper integration of our solution and potentially also of Wavelength with the 5G network. So now that we have it running on the edge, there are a lot of cool things that we can imagine that we can do with the network, which starts by making the network more aware of what we're doing, making the 5G network understand that our camera traffic, our uplink camera traffic is a very sensitive type of traffic, and we probably want to reserve some bandwidth, do some 5G slicing. So when the network understands that the service running on it has some specific requirements, we can get a much better performance, a more reliable type of solution, serve more end users in the end. So that's for us really the next step. We're working with 5G carriers in those use cases, and we're really looking forward. And as Ali was saying, 5G is really software defined. So all those things, the network has been designed for all those use cases. So all those are things are there to be integrated, and we see significant advantages to those.
Okay, Sebastian, thank you very much. That was a really exciting overview. So I'd like to just hand over finally to Ria, my colleague, who's just going to wrap up on, we've heard a lot about application developers. Why should operators be interested in this opportunity? Ria, over to you.
Great, thanks, Phil. So why should mobile operators embrace this opportunity? There are a few key reasons why 5G and Edge present an opportunity for telcos, as well as developers and enterprises, as we've heard. So firstly, telcos have existing assets that they can exploit. There's also demand from the application side for telco-enabled capabilities. And then also telcos are looking to secure a return on the investments that they've made in 5G. So 5G and Edge could be a tool to achieve that. And finally, telcos have internal objectives, specifically around growing their revenues. And again, this presents them with a way to achieve that. So firstly, in terms of exploiting infrastructure synergies, telcos have existing edge infrastructure and they're continuing to build that out. further distributing their network sites with data centers. And so those sites that they're already investing in to run their own networks will have the capacity to host edge applications as well. So it should be relatively straightforward for telcos to take advantage of those infrastructure synergies. And then secondly, meeting the demands of new applications. Telcos will be in a good position to meet the demands of these new applications that we're hearing about by coupling the network and compute functions. So the network is becoming more relevant and applications can't just rely on compute. So for example, there'll be instances where the network becomes congested and the application will need to be able to respond before it starts to suffer because of the network congestion. And to achieve that, the application will need to be able to interface with the network. And if there is congestion, customer workloads need to be able to be moved from one, for example, wavelength site to another. And that's difficult if they're not tightly coupled. So if we take the example of an application like gaming, lots of streaming traffic can put strain on the network. And if there is a peak in user demand, it's important to prevent a reduction of streaming quality for the end users if the network does become overloaded, and so to therefore be able to move workloads to other sites before that happens. So there needs to be greater visibility for the application locally of what's happening in the network locally, and enabling it to provide some level of instruction to the network so that action can be taken before it impacts the service quality. And thirdly, securing a return on 5G investments. Telcos are obviously already investing in 5G, and so they want to be able to secure revenue on top of those infrastructure investments. And they want to be able to maintain and grow their market share. And in order to achieve that, they'll need these kind of differentiated offerings. So they want to be able to augment their 5G offerings and capabilities and deliver this kind of 5G premium service to ensure that they can grow revenues with 5G. So that kind of leads into the final point around the fact that telcos want to grow their enterprise revenues, and by embracing this edge and 5G opportunity, they'll be better placed to do that. So they're facing declining revenue growth, especially with the commoditization of connectivity, and they're looking to bolster their propositions, particularly in the B2B to X space, and find these new opportunities for revenue growth by growing their enterprise business. And to achieve that, there is obviously a lot of hype around 5G, and there are big promises that are being made on the sort of new and dynamic use cases that it could enable across lots of different industries. Obviously, we've heard from Sebastian about YBVR, but there are lots of use cases that are being deployed or at least explored in many industries like manufacturing and healthcare, retail, and so on. And industries, especially in the conversations that we're having, they're looking to become more and more automated and make more efficient use of their resources. So telcos can exploit this opportunity and engage a range of customers across different industry verticals. But this hype, especially the 5G hype, is also setting a lot of high customer expectations. And while 5G does have many capabilities beyond those of previous generations of connectivity, as Dalia outlined, it is still very much an evolution. So 5G standards have set very specific targets around low latency and reliable coverage, and there are lots of use cases emerging that will depend on things like ultra low latency that can't be achieved with 5G alone. But 5G and edge computing together can enable telcos to offer those high quality solutions to customers and meet some of those expectations, kind of further enabling them to become these kind of enablers for those more advanced solutions. So for example, in the context of latency, taking the example of gaming again, high-end gaming applications can have latency requirements of sub 30 milliseconds. And in the case of AR/VR gaming, that may need to be as low as sub 10 milliseconds to ensure that kind of critical high quality and immersive end user experience. So being able to host a game closer to end users and have those workloads running at more distributed edge sites in the mobile network will reduce the round trip time and ensure that much lower latency. So telcos can engage different verticals beyond just providing connectivity and augment those 5G capabilities to offer these new B2B services. So just to summarize, 5G and Edge do present a strong opportunity for telcos. Telcos have the infrastructure already that they can exploit. Secondly, there's the demand for these applications with the coupled network and compute functions. And then also there's this internal drive to grow revenues within telcos and secure those that return on the investments that they're making in 5G.
Great, thank you very much. Right, so what I'm going to do now is invite everyone on the panel to turn on their cameras, and we're going to run through some of these questions that people have submitted. Please continue to submit your questions along the way. Okay, so welcome back all the panelists, and we've got a lot of people on the webinar, so I'm sure lots of interesting questions have come in. We'll do our best to process them. As I said, those questions we're not able to answer, we will try and answer after the webinar and send everyone our responses. So do bear with us, and do keep sending your questions in, although I can see there's quite a lot here we're going to have to get through. So I'll start straight away, given that we haven't got much time left. And I'll kick off with a question here, which I think we kind of answered. The question may have come in before it was covered, but I'm going to send it back to Sebastian, which is, what for you are the key benefits of Edge and Wavelength over the regional cloud? And if you were to summarize that.
Yeah, so I think you're right. We've covered most of them. For us, as YBVR, the key benefit is the data saving. It's just not sending our massive amount of data, video data, over the public internet, because that would just simply not work for us, right? So compared to the region, is just being able to have the computing close enough, like really connected to the last mile, where the last mile is your 5G network. So we save all the data. Our traffic stays in the 5G network, which is a managed network where we can have control. We can do smarter things on that network when we work with operators, and all that saving and the amount of data we can send through the network with certain guarantees of quality, right? Also a little bit the latency. So there's less latency, and that helps also to our use case. So latency and traffic for us are really the two big differences compared to the region.
Right. No, thank you. The next question here, it's a sort of a question, again, it must be from a developer to you, Sebastian. I've got here is, to what extent did you have to make any changes, be it on the client side or in the back end?
Not many, really. On our client side, it was literally 0 changes. It was just a configuration change. It was just basically pointing the clients, instead of pointing them to our endpoint residing on the central AWS region, changing the configuration, because that's like dynamic in our system, pointing to the Wavelength Zone. And on the backend side of things, it was mostly infrastructure. Basically, we didn't have to change our software. Our video streaming software remained the same. It was just infrastructure changes. It was just accounting for that the differences in the networking and this carrier gateway that we spoke about. But really literally no software changes. Absolutely 0 changes on the client side, and just infrastructure changes on the backend side.
Okay, so that's the point you're making, pretty seamless. And I've got a similar sort of question, but this time I'm going to direct it at Bala, which is more, were there any changes that AWS had to make to your set of services in order to support Mobile Edge? For example, how do applications and devices know which wavelength instance to connect to?
Yeah, so the answer is very similar to what Sebastian said. We didn't have to make a significant amount of changes to the services, right? Like I said before, it is the same AWS infrastructure that you are using in Wavelength Zone that you've been used to in the regions, right? So there are some new concepts that we have had to create, though. For the first one, I briefly talked about, that is the carrier gateway. And if you think of the Wavelength Zone, these are infrastructure deployments sitting in a telco data center. And if they have to be part of the telco network, when they boot up, they need to get an IP address that is routable in the telecommunication service provider's network. And they also need an IP address that allows them to go back and access the services in the region seamlessly. So this concept of carrier gateway is essentially a NAT functionality that translates between private IP addresses in your VPC and the IP addresses from the telecommunication service provider. So that's a new concept we have had to introduce, just so that we are bridging between the telecommunication network and the region seamlessly, right? And along with that, if you want to go a little more deeper, there's some, we talk about a network border group. That's essentially the pool of IP addresses that you get from the carriers that are being used by the carrier gateway to get translated. Now, the second part you asked, what is it that you need to do?
I think, well, there was a specific, for example, the example was how do applications or devices.
Yeah. Okay, sorry about that. I kind of lost track of the question there. The second part you asked is, how do applications know what's the closest region for them, right? If you were on a public internet-based service, then latency-based DNS routing works fine. But on a mobile network, that doesn't work that well, because the results you get might be based on the location of the resolver, not on the device, on the location of the actual device. So what we need to do is we need to find out what's the exact closest edge location. And it essentially is a two-step process. So you register, when you are deploying your applications in the wavelength zone, you register your application resources in a registry. So you can use a service like AWS Cloud Map to register these endpoints, and then you annotate that with with the name of the wavelength zone and the geolocation, and then you essentially get the geolocation of your device or of that endpoint, and that will allow you to determine what is the closest wavelength zone that you should point your resources to. So it's essentially registering your services with a service like AWS Cloud Map, and then on the client end or the device end, you are using geolocation to find out what's the closest wavelength zone you can reach to. And you can do that through APIs to get the location and figure out what network you are on.
So that discovery is pretty automated then?
Yes. Yeah, it's built into the applications.
Okay. No, thanks for that. I've got another question, I think, from a developer here, which is, I'm going to send it back to you, Sebastian, again. Yeah, as a developer, can you give me any guidance on how I should think about the trade-off in cost and performance for Wavelength? Because presumably there is a cost. So how do I think about that?
Yeah, so there's a little bit higher cost when we compare it to the central region, but of course there's an added value here, right? And for us, it was quite a simple economics, right? Like the economics for this for YBVR was, if we use Wavelength, it opens a new use case. It really literally opens us a new market. The other technically viable option that we had to do this in stadium streaming is deploying hardware in the stadiums. So for us, the economics was comparing deploying a rack of servers, of computers into every stadium that we want to service, which is extremely expensive, wiring that rack and powering it and everything, as opposed to using Wavelength. So for us, those economics were very simple. For other use cases, different developers, I guess you will have to do your math. But my guess is this is going to be quite common for many people out there, that it's not so much the economics, but opening completely new use cases, opening new ideas, opening new possibilities, things that were not technically feasible because the latency was too high, because the bandwidth was not enough, are now going to be an option, right? So this is really opening new use cases. So in our perspective, we were very happy to pay that extra, which is not a lot anyway, right? But that extra cost, because of the added value, is massive for us.
Okay, so it's interesting when you're sort of doing an ROI on it. It can be, well, it's that or nothing. So it's a simple ROI. If we want to get into in stadium, basically the alternatives are going to be very, very expensive or prohibitive. And also the interesting thing is that comparison isn't necessarily between Wavelength and regional cloud. It could be on-prem versus Wavelength, because those are the alternatives.
Yeah, exactly.
We're looking at.
That was literally our case. Yeah.
Okay, no, that's interesting. I'm going to move on in the interest of time. And the next question here, it's a little bit more, I think, around AWS's other services. So I'm going to send this back to you, Bala, which is the questions asked here is what are the main differences between AWS's different edge services, and what type of application you put on Wavelength? And the comparison that's been provided here to me is Snowball, Outpost, Local Zone, or Region. I'm not going to ask you to define all of those, but which kind of application is more Wavelength, and maybe just touch on some of those others that have been listed here.
Yeah, so this is a fairly common question, so I'm not surprised that it showed up in the chat there. There are multiple options that you have to deploy applications on the edge, and each of them is different. That's why they are different services, right? So let me talk about Snowball Edge. Snowball Edge first, right? Snowball Edge is essentially a rugged device that you can use, and most of the time you use Snowball Edge when you are in an environment that has intermittent connectivity. So, like a manufacturing floor or a industrial shop floor, or military locations or maritime operations. You use Snowball Edge when you want to make sure that you can still process data and store data where you have limited or intermittent connectivity. So that's really the big use of Snowball Edge, and that is available in two different variants. There's a storage optimized one, which you can use to store local data and then have that shipped back to AWS whenever you have connectivity. And then there's a compute optimized version of Snowball Edge as well, which has some GPUs built in, so you could use that to run machine learning applications or video analysis applications. Now, Outpost, Snowball, Outpost, Wavelength, and Local Zones are also closely related because they're very similar hardware that are located at different locations in the edge. Outpost, the biggest difference is Outpost is a single tenancy mode of operation. So if you are a customer, you are essentially owning and you're leasing that equipment, and it sits in your data center or it's co-located on your premises. So you can use that for applications where you think you need a hybrid on-premises versus cloud, on-premises cloud environment, applications that need to run in a hybrid mode of operation where you need some data to stay on-premises in your data center, right? So those kind of applications are really well suited for Outpost because that's a hardware that is sitting. It's a fully managed AWS service, but the hardware is actually sitting in your data center, and you are the only tenant on that. Now, Local Zones is a multi-tenant application, right? So this is edge infrastructure that is sitting in AWS locations. It's managed by AWS. It's sitting in an AWS location, and it's very similar to a region or an availability zone. Anybody can access those local zones and run applications that need low latency access to end users. And most of the times, the plan is to have local zones closer to large urban centers. Right? So it is independent of the access mechanism. It is sitting in an AWS location. It is multi-tenant. Now, Wavelength is also AWS managed hardware, but it is sitting in a CSP or a telco data center. So it is still managed by AWS, but it is physically sitting in a telco data center. And it is dependent on connectivity, right? So you can access applications or access that wavelength zone only through that carrier's network. So a Verizon wavelength zone can be accessed by devices that are on Verizon's 5G network. A Vodafone wavelength zone will be accessed by devices that are on Vodafone's network. So they're not access independent in terms of being accessed through a telecommunication network, but it is still multi-tenant, right? So it is still anybody can access that. You're running, multiple users, multiple ISVs, multiple applications running on it, and it is still managed by AWS, but it is sitting somewhere else. The access criteria is limited to the network you're on. whereas local zones is much more general.
Thanks for that explanation. I hope that the question is satisfied. That was very clear, actually, and I helped clarify things for the audience. I'm in interest of time. I'm going to run through the next questions quite quickly, so I'm going to ask all of you to respond as quickly, as briefly as possible. There's an interesting, slightly different question here. We've touched on it, but do we have a view of the applications and the key differences between applications that are on-premise versus the network edge? And I'm going to direct that to Ria. Do we have a kind of view about what sort of applications are likely to reside in the network edge versus on-premise edge?
Yeah, thanks, Phil. So I think it really depends on the specific requirements of the industry application and the enterprise. But the two big reasons that we're seeing for why an application might need to be hosted on-premise rather than the network, especially for mission-critical applications. So, for example, in manufacturing, with IoT, for example, there are very specific requirements around having ultra-low latency and reliability. And, depending on the application, there can sometimes be fatal consequences if, for example, those low latency requirements aren't met, for example, with injury to individuals. So being able to, have that kind of processing and compute on site, the closer that the edge server is to the end device or the end user, will only mean kind of, lower latency. And then the second big reason is around data privacy. So, obviously there are growing concerns around data privacy, and especially in industries like healthcare, which are dealing with very sensitive patient data. A lot of the time they will want to keep that data on premise. Obviously, so for some use cases that won't be possible, especially more mobile use cases like connected ambulances, for example. But I think being able as much as possible to keep sensitive data locally will be critical for certain applications. And there will be other instances, for example, with content delivery. So, a university, for example, might know that they're going to have very localized demand for streaming services. So they may want an on-premise edge server to be able to kind of ensure the best streaming experience for their students. But the big reasons that we're seeing are mission critical applications and data privacy.
Okay, thank you. Otherwise, the two are obviously both viable alternatives for a lot of what we hear. And I guess the converse is true, Ria. There'll be some applications where it doesn't make sense for on-premise because of the nature of the customer base and their mobility. So coming back, just want to run through the last few questions very quickly, if you could, please, because we are coming up to the hour. With the partnerships in place that you've got, AWS has got with the likes of Verizon, can you share any use cases, but not limited to any autonomous driving tests, and any indication of adoption rate? So quite a few questions in there, Bala, but can you try and answer that in 1 minute?
Yeah. Yes, I will try to. As I mentioned briefly in my slides, right, there are use cases in different verticals that we are seeing that are being tried, right? One example is Avisha that uses wavelength zones to process or help physicians in diagnosis when medical procedures are going on, right? They have a really cool application where they stream the data coming from diagnostic devices, and that they use machine learning inference at the edge to identify polyps that were missed by the naked eye during examination, and point doctors to those areas where they should probably pay a little more, or they can go and investigate more, right? So this is real-time diagnostic assistance. That's a healthcare application that we are seeing. Sorry about the interruption. Was the question, can you talk about applications beyond autonomous driving, or?
Well, yeah, but including, sorry, but not limited to. So okay. I wasn't very clear. Yeah. Including, but not limited to autonomous.
So there is definitely a lot of interest we are seeing in autonomous driving related applications, especially the CV2X platforms. One of, we talked about, recently we have talked about two applications that we are seeing, specifically LG trying authentication as a service for CV2X platform, right? So they use wavelength zones so that they can identify and detect bad actors in a vehicle to anything communications. You do not want, when the entire operation of autonomous vehicles is dependent on getting information from other vehicles and other devices, you want to make sure that there are no rogue actors providing wrong information on which other vehicles might act. And that needs to happen in real time. So they use wavelength zones to run their authentication as a service platform. And then there's a startup called Savari where they're using, they're running their V2X platforms to essentially warn vehicles and warn pedestrians, warn about pedestrians before even they are visible, right? So this is again low latency communication between vehicles and the infrastructure and the traffic infrastructure. And then there's a big cluster of use cases in the media and entertainment field, and that includes communal viewing, AR, VR applications, and there are, the ability to insert data and statistics and analysis into live streams. So there's a lot of interest in media and entertainment use case.
Okay, great. I'm very close to time. We've only got about a minute left, I'm afraid, for this last question. As I say to those of you who've submitted your other questions, we will be sending the results individually, so we will get back to you with the responses. But for this last question, which I am going to redirect again to Sebastian, it's about how mature are the applications you've shown us. Is it peer proof of concept, or is it something in production? And are you seeing real traction or adoption? Of course, these are difficult times for live performances, not the ideal time to ask the question, but disregarding the current epidemic, what's the level of interest and what's the realistic adoption rate you're expecting from this?
Yeah, exactly. As you mentioned, these are complicated times, especially for the in-venue use case, right? So we're coming from a mature solution. So our home viewing over the top solution is a mature solution. It's working well. We've done a lot of live events with it already, so it has like very good commercial traction. And on the other hand, the low latency solution, the one that is based on Wavelength, it's really something very new because it's something that was literally enabled by Wavelength. Right? It's something we did together with Verizon, as you saw in that video, based on Wavelength, and we were expecting to be in production today with people in stadiums. We had events and dates identified, which of course got canceled and postponed and everything. So the solution is ready. It's it has production grade, but we have not been able yet to identify which is going to be our first in-venue event with real audience, with real people, because pretty much worldwide, in most countries, stadiums are closed. Specifically working with Verizon in the US, it's really complicated right now. But we're looking forward to it. We think that 2021 is going to be a much better year in that regard. And as soon as the stadiums open, the solution is ready. As soon as the concert venues open, the solution is ready. On the other hand, we're already increasing our footprint with the in-home viewing, right? Like if you can't really go to the stadium, we can bring the stadium to your home. And as soon as people can return to stadiums, they will have a much better experience, a much more enhanced and rich experience.
Well, thank you very much. That's something I'm sure we're all looking forward to. I'd like to thank Sebastian, I'd like to thank Bala, and obviously Ria and Dalia for today's webinar. Great stuff. And all of you who have been watching, we will get back to you, as I said, with the presentation material, with those of you who submitted questions and we haven't been able to answer answers to them, and obviously a link to a recording of this video. Thank you, and have a good evening and afternoon.
Thank you.
Thank you.
Thanks.
Right.